You know, medical imaging is at the very heart of almost every critical decision made in a hospital. But what happens when the software powering it is literally decades out of date? Today, we're going to deconstruct radiology and see how a completely new way of thinking is rebuilding it from the ground up.
I want you to think about this for a second. For decades, doctors have had to completely change the way they work just to fit the software they're given. It's just completely backwards, right? So what if we flip that? What if the technology was actually built to adapt to them, to their hospital, their specialty, and most importantly, their patients?
All right, so to really understand the solution here, we first have to get our heads around the problem. And that problem, well, it can pretty much be summed up as the radiology bottleneck.
So, the systems that most hospitals are still using today are called RIS PACS, and you should think of them as a product of the late 20th century, a single, massive, totally inflexible block of code, a monolith. It was designed back when radiology departments were these isolated silos, and that is just not how modern medicine works anymore.
And this is where it all falls apart. The old model was completely one-size-fits-all, but modern medicine is incredibly specialized. Those old systems were rigid, but today's healthcare networks span multiple locations, sometimes across the country. They used to work in isolation, but now they absolutely must connect seamlessly with electronic medical records, EMRs, and all the new AI tools. That monolith was built for a world that, frankly, no longer exists.
So, if the monolith is the problem, what's the solution? Well, you break it apart. It's time to deconstruct.
Let's look at why this one-size-fits-all approach just doesn't cut it in the real world. A radiologist who's just reading simple x-rays all day needs a super fast, lightweight viewer. But a neuroradiologist analyzing a complex brain MRI, they need powerful, advanced 3D visualization tools. A big chain of clinics needs to balance workloads across different cities, while a single hospital might just care about tight integration with its own EMR. A monolith forces every single one of them into the same clunky, ill-fitting system.
This quote right here, it just perfectly captures the new philosophy. It's a complete 180 from the old way of thinking. The workflow has to adapt to the institution, not the other way around, period.
And this whole philosophy, it actually has a name: Deconstructed Workflow Architecture. It's all about breaking that giant monolith into smaller, modular, independent components. Honestly, the best way to think about it is like Legos. Instead of being stopped with one giant, pre-made model, you get a box of bricks. You can pick and choose the exact pieces you need to build the perfect system for you.
And these are your building blocks. Each core function, scheduling, reporting, AI integration, you name it, is its own independent module. This is so key. It means a hospital can upgrade its reporting system without ever touching its scheduling tool. They can swap out one piece without having to demolish the whole structure. Now that is true flexibility.
Okay, so that's the theory, which is great. But what does this actually look like for a patient and their doctor? Let's walk through what this new workflow looks like in action.
This is the whole patient journey, a completely seamless continuum, all the way from the doctor's initial order to the final report. And you'll see, intelligence is built in at every single step. Let's start at the beginning.
So it all kicks off with the treating physician, right inside the patient's electronic medical record. And the moment that order is placed, the system is already working in the background, pulling clinical data, checking for prerequisites, like did the patient need to fast? You see? It's smart from the very first click.
Okay, so once the images are taken, this is where the intelligent routing really kicks in. Instead of just landing in some generic first-in, first-out queue, an AI-assisted engine analyzes the case. It looks at the subspecialty needed, the urgency, even the current workload of every available radiologist, all to find the perfect match. This makes sure that a complex brain scan actually goes to a neuroradiologist, which optimizes for both quality and speed.
And when that case finally lands with the right radiologist, they get to choose their tools. They're not forced into some single clunky interface anymore. They can use a simple web viewer for a routine case, or they can fire up an advanced 3D tool for something really complex. It's all about empowering the experts with the tools they actually prefer, which, you can imagine, directly boosts their productivity and just makes their day better.
So when you put all of these pieces together, what are the big picture benefits? Let's quickly sum up the real advantages of this adaptive approach.
The advantages here are pretty profound. Because it's modular, hospitals only build what they actually need. No more bloated, expensive software. The workflow is adaptive, so it can be configured for any specialty. AI is woven right in to automate tasks and boost productivity. And maybe most crucially, it's built to be interoperable. It actually connects with other systems, breaking down those data silos instead of creating new ones.
Now, the backbone for all of this, especially for those huge health networks, is what's called a distributed cloud framework. The easiest way to think about it is like a franchise model. Corporate HQ sets the overall standards and rules, but each local store manages its own day-to-day operations. You get that perfect blend of centralized governance with local freedom.
So, what does this all really add up to? Well, it's so much more than just better software. It's about fundamentally redefining what a radiology workflow can even be.
And that brings us to the final, really big picture question. This isn't just some IT upgrade. By moving from a rigid, old-school system to an intelligent, adaptive ecosystem, we are literally building the foundation for a new era of precision medicine. So the real question for all of us is, how will this new level of precision shape the future of our own healthcare? Because in the end, that's what this all is. It's not just a new risk or a new PACS system. It's radiology workflow redefined.